Let's talk about writing the standard equation for an ellipse. Not only writing the standard equation, but using it to find different values of the ellipse. Now, in my last video, I went over how to use the distance formula with the ellipse equation. So if you're curious about that, you're going to want to tune into my other ellipse video. In this one, I'll be focusing on using the table and information in the table that contains all of the goodness about ellipse, using it to find information and write the ellipse equation that way. So no distance formula here. Alright, so an ellipse is the set of all points in a plane whose distances to two fixed points add to the same constant. Notice how much more sophisticated and complicated this definition is just compared to a circle, and that's because circles are perfectly symmetrical. So it's easy for us to just define a center and a radius and draw a circle, because we know that if we just measure the length of the radius all the way around that center point, we'll draw a circle. And in the case of an ellipse, not so simple. So we also have to define, radius is not applicable here because we don't have it equidistant from every point on the figure. So now we have to define a couple additional terms. Let's start with major axis and minor axis. So major axis will always be where more length occurs. So in a horizontal ellipse, the major axis is the x-axis, and you can just see there's more width to this than height. On the other hand, in a vertical ellipse, there's more height than width. You can see that this is pretty tall. The distance from the two end red points is much greater than the end points in green. So major axis is the longer, minor axis is the other. So if I have a horizontal ellipse, remember always associate horizontal and x. Horizontal has a major x-axis, vertical has major y. Horizontal has a minor y-axis, vertical has a minor x-axis. Now you all know what vertices are, but in this case we talk about vertices as the endpoints of the major axis, because we need a way to tell the difference between the points in red and the points in green. So the points in red become the vertices, which are the endpoints on the major axis, and the points in green become our co-vertices, which are the endpoints of the minor axis. We also have our focus 1 and focus 2, which are the two fixed points referred to in the definition. So an ellipse is the set of all points in a plane whose distances, so the ellipse, think of this figure in red as actually just a bunch of points that are so close together you can't see any space between them. So it's actually infinitely many little points that appear in that shape. So an ellipse is this set of points whose distances to two fixed points add to the same constant. Meaning, if I pick some random point, let's say I have a point here, if I were to measure the distance from that point to here and that point to here, it would be the same that the sum of those two distances, so if we call that D1 and D2, the sum of D1 and D2 would equal the sum of this D1 and this D2. And if I put my point over here, this D1 and this D2, if I put my point here. So no matter where I put my point and make my measurements from D1 to D2, when I add those two distances together, I get the same constant, called the constant sum. Okay. Now, the standard form for the equation of an ellipse, centered, notice this is centered at the origin, looks like this. Okay? Notice that as a convention, horizontal ellipses have a leading x, vertical have a leading y. So it's important right off the bat to differentiate between horizontal and vertical ellipses. So horizontal will have a leading x, vertical will have a leading y. Notice also, if you consider a vertice, horizontal has zeros for the y value in foci and vertices. Vertical have a 0 for the x value. Okay? And then co-vertices, of course, are the opposite. The values a, b, and c, so a, this b, and this c, are related by this equation, a squared minus b squared equals c squared. Meaning, if you know a and b and want to find c, you can use this rule to find c. Let me show you what I mean. So let's say they ask us to write an equation in standard form for the ellipse centered at the origin with vertex 6, 0 and co-vertex 0, 4. So we use our table to help us out. Let's note a few things. So first of all, notice that our vertex 6, 0 has an x value but then has y as 0. So this is going to tell us whether we're working with horizontal or vertical. So let's look at vertices here. In a horizontal ellipse, there is an x value and 0 for the y value. Just like ours, right? We have 6 as our x value and 0 for our y value. So we must be working with a horizontal ellipse, meaning we can ignore everything on this side. If you ignore that right-hand side of the table, we really are working with a very little amount of information, and it'll be easy for us to sort it out. So let's figure out what we know so far. So if 6 is the x value of the vertices, or of the vertex, that means 6 must be equal to a. 6 is a. We also have our co-vertex, 0, 4. If you look at co-vertex, 4 corresponds with b. So 4 is b. If you look at the equation for a horizontal ellipse, all you need are a and b to define it. So it's just defined by vertex and co-vertex. Meaning, if I write out x squared over, leave that blank for now, y squared over equals 1, so this is the skeleton, I can fill in the rest already, right? So I know that 6 is a, so I'll write a squared, and I know that b is 4, so I'll write 4 squared. The only remaining step I could take would be to, oops, that should be a 6 squared, would be to just simplify. So 6 squared is 36, 4 squared is 16. So here's the equation in standard form for this ellipse, and we found it by using the vertex and co-vertex to first tell us whether we had a horizontal or vertical ellipse, and then fill in the equation. Let's do another example. All right, once again, we're given a vertex and a co-vertex, and we need to figure out what's the first thing you want to know. Is this horizontal or vertical? Let's use, we used vertex last time to figure it out. Let's figure it out using the co-vertex. So notice that you've got a 0 in your x and a 3 as y. So if you look over here at horizontal, it matches up, right? We have 0 as our x value and 3, a numerical value for y. So once again, we're dealing with a horizontal, and we can ignore everything on the vertical side. It's just extra information. So what do we know? We know that 3 is the y value, or yes, the y value of our co-vertice, meaning that 3 is equal to b. We also have our vertex. We know that 8 is the x value of the vertex. So if 8 is the x value, then 8 is equal to a. Since all we need are a and b in order to define this equation, we are ready to fill in our information. So a is 8, so I write 8 squared. B is 3, I write 3 squared. And then I simplify. X squared over 64 plus y squared over 9 equals 1. This is the equation in standard form for this ellipse. Let's practice again. All right, so we've got focus and co-vertex. Focus and co-vertex. So this is different because last time we had vertex and co-vertex. So let's see how this changes our approach. All right, so I'll use the focus to determine what we've got here. So my focus is 0, 3, meaning I have 0 for x and a value for y. If I look at horizontal, well, they've got a value for x and 0 for y, so that doesn't match with what I have. So this is not a horizontal ellipse, it's vertical. So now I know that this is going to be the framework for writing my equation. You can see that foci corresponds with C, so C is equal to 3. covertex, as we found out before, covertex corresponds with b, so b equals 5. Now, let's go ahead and write out our framework for the equation. Y squared over something plus x squared over something equals 1. All right, let's fill in our information. So b is 5, so 5 goes here. But I don't have a, I have b and c. So how am I going to identify what a is? Well, remember that my values are related by a squared minus b squared equals c squared. So I'm going to have to use that to find a. So a squared, I don't know, minus b squared, so b is 5, so b squared is 25. So a squared minus 25 equals c squared. C is 3, so c squared is 9. A squared minus 25 equals 9. Solving for a, I add 25 to both sides. I find that a squared equals 34. Now, you're going to be tempted to say, oh, well then I need to take the square root, but you don't because we need a squared. So, I will plug a squared directly into my equation, 34. So now I've got y squared over 34 plus x squared over 25 equals 1. And that's the equation for this ellipse centered at the origin.